I'm going to start at question 20. Everything before it was vocabulary, so you should be able to look those up. In question number 20, looking for a pattern. Okay, if you notice from 16 to 4, and then 4 to 1, and then the 1 to 1/4, and 1 to 1/16, we're dividing successive terms by 4. Okay, and then that's really easy to see here. Okay, with these first 3 terms. But remember that dividing by 4 is the same thing as multiplying by 1/4. So if I want to go from 1/4 to 1/16, I take 1/4 and then multiply it by 1/4. So if I want to go 1/16 to that number, I'm going to go 1/16 times 1/4. And that's going to give me 1 over 64. Okay. Then if I want to go, so that term right there, 1 over 64. If I want to go from 164 to the next term, I'm going to take and multiply 164 times 1/4, and that's going to end up giving me 256. So 1 over 256 will be that second term. Okay. Then if I want to go from 1 over 256 to the next term, I'll multiply that by 1/4, and that's going to give me 1 over 1024. So my 3 terms here are 1 over 64, 1 over 256, and 1 over 1024. A lot of people try to put the decimals in here. That's not the pattern. Okay, the pattern is fractions. Okay, again, looking at patterns, and here the pattern, they're asking about the shading. They don't care about the shape. So I start to see that the pattern starts off as not shaded, and then shaded, and then striped, and then not shaded, shaded, and striped. Okay, now they ask me to go out to the 13th, which is in a 30th. Never mind that. So ask me to go out to 30th. So I don't want to write that out 30 times. Okay. So I recognize that the third shape is always the same. So that one's the third one is striped. Here in my list, the 6th one would be striped. The 9th one would be striped. If I write it out again, the 12th one would be striped, and then the 15th one would be striped. Multiples of 3 are striped. Okay, so they want the 30th term. Okay, so what I'm going to do is I'm going to find a number that is divisible by 3 that is close to 30. Okay, and that is 30 itself. So I divide that by 3, I get 10. So what that tells me, because 3 evenly divided 30, that tells me that the 30th term is the same exact thing as the third term. Because if you were to write this pattern out 10 times, you would get to the 30th term, and the 30th term is going to end on striped. Okay. Now, if they wanted, let's do another example. Let's say if they wanted the 43rd term. Okay. If we want the 43rd term, I'm going to find a number that's close to 43 that's divisible by 3. 42 is one of those numbers. 42 divided by 3 evenly gives me, what, 14? Okay. So this tells me that the 42nd term, because it was divisible by 3 evenly, the 42nd term is the same thing as the third term. Okay. If I were to write this pattern out 14 times, the last term that I would see, the 42nd term, is going to be striped. But I don't want the 42nd term, I want the 43rd term. So if the 42nd, if this is the 42nd term, then the 43rd term is going to be not shaded. Okay. An alternative way of doing this is to actually use your calculator. And whatever term we have, okay, I want the 43rd term, I'll divide that by 3, because that's how many things are in my pattern. Hit enter, gives me that remainder. okay, or that result, that quotient. I'll subtract the 14, and the 0.3333 tells me ultimately that I am into the next cycle a third of the way. Okay, so I'll multiply that by 3, and a third of the way in the next cycle would be one term. Okay, so that 1 matches up to, if I'm going to use this pattern, that's the first term, that's the second term, that's the third term. If I do this pattern of subtracting the 14 and then taking the remainder here and multiplying by 3 and getting a 1, I'm going to then match that 1 up with that term, and now I see that the 43rd term is not shaded. If I wanted the 124th term, divide that by 3, I get that. I'll subtract the 41, multiply that by 3, and I get a 1 again, so the 124th term is the same as the first term. If I wanted the 145th term, divide that by 3, we get 48.33 again. Okay, so subtract 48. This will end up again, same pattern, give me the first term. If I go 146, divide that by 3. Here I get a different remainder. I'll subtract the 48, multiply that 0.6666 by 3, that's how many terms are in my pattern, and I get 2. So that tells me the 146th term is the same thing as the second term, so the 146th term is going to be shaded. Identify the hypothesis. Remember, the hypothesis is the if part. So an animal is a dolphin. And then the conclusion is the then part. It is a mammal. Two statements have the same truth value are equivalent statements. Okay, write that as a conditional. So if two statements have the same truth value, then they are equivalent statements. So we're looking for option C here. 24, write the converse. So the converse is flipping those. If I am in the West, then I am in Oregon. So option D. It says determine the truth value. If you're in the West, then you're in Oregon. No, that's false. You could be in the West, which is California, and still be in the West. So you could be somewhere else other than Oregon. They're saying that the West, the only state out there is Oregon. That's not true. That's false. Right, the inverse. The inverse, remember, is negating both of these of the original conditional. So if I'm not in Oregon, then I'm not in the West. If I am not in Oregon, then I'm not in the West. Okay? So determine truth value. If I'm not in Oregon, then I'm not in the West. Well, that's false. Okay? If I'm not in Oregon, I could be in California. Write the contrapositive. The contrapositive is taking the original one, flipping it, and then taking the negation of both sides. So if I am not in the West, then I am not in Oregon. If I am not in the West, then I am not in Oregon, which is option A. And it says determine the truth value of that. Okay, well, this is the contrapositive. If I'm not in the West, which will mean I have to be in the East. Okay, then I'm not in Oregon. Well, that's true, because Oregon's not in the East. Okay, so this is going to be true. Okay, remember the conditional and the contrapositive both have to be true. That's a true statement right there. That's a true statement. The inverse and the converse, they have to be logically equivalent as well. They were both false. We're just asking here to identify the contrapositive, identify the inverse, the converse, that kind of stuff. So conditional statement. Now, I'm just going to go find, it says if angle 1 measures 38 degrees, then angle 1 is acute. I'm going to find if angle 1 is acute, then it measures 38 degrees. So this one here, what I just did is the converse. Okay, then I'm going to look at this statement here. I'm going to negate both sides. So if angle 1 does not measure 38, then angle 1 is not acute. That's going to be the inverse. And then my only option here then would be that this is the contrapositive. And you notice that is the combination of the inverse and the converse. Sorry, yeah, the inverse and the converse on my conditional statement. And one now is the conditional true. If angle 1 measures 38 degrees, then it's acute. Yeah, that's true. So the conditional is true. I automatically know the contrapositive is true. So just get that done. Now they ask me, is the converse true? If angle 1 is acute, then angle 1 measures 38 degrees. So what they're saying there is that if you have an acute angle, if I tell you have an acute angle, you know it to be 38 degrees. And that's false. You know it could be 45 degrees. Acute angles are anything less than 90 and greater than 0. So that's false. So then the inverse also has to be false. If M is the midpoint of a segment AB, then M is between A and B, and AM equals MB. That is true. Okay, that's the definition of a midpoint. They want to then, they say if M is between A and B, and AM equals MB, and M is the midpoint of AB, that statement there, all we've done is we flip things, so that is the converse. If M is not the midpoint, okay, so there we're keeping the original conditional in that same order, but now we're negating, we're putting the word not, so that has to be the inverse. And this must be then the contrapositive. Determine the truth value of the conditional. If M is the midpoint of AB, then M is between AB and AM equals MB. So that is true. The conditional is true, so the contrapositive is true. Now the converse says if M is between A and B and AM equals MB, then M is the midpoint of segment AB. That's true. Okay, remember earlier I said this is the definition of a midpoint. If we read that, we should recognize that that's the definition. And with definitions, they can always be written as true biconditionals. And the true biconditional, all four of these things should be true. We want to know what property is going on here. AD plus DB equals AB. AD plus DB, that's the segment addition postulate. Measure of angle 1 plus measure of angle 2. If I take those two angles together and add them, I should get angle CDB. That's angle addition postulate. Here, angle 2 is congruent to angle 6 because their vertical angles are congruent. If D is the midpoint of AB, then AD equals DB. That's the definition of a midpoint. If ray DF bisects angle CDB, then angle 1 is congruent to angle 2. That's the definition of an angle bisector. Alright, so here, I told you this part here, F was definition of linear pairs. Okay, I just gave that to you. Now I want F1, ADF and FDB are supplementary. ADF, so ADF is that angle there. Let's see if I can draw on it. So ADF is that angle there, and then we're going to add to it FDB. If we look at that one there, okay, those two together form that straight line. So those two things are supplementary because they form a linear pair. And we have linear pair postulate said if two angles are adjacent, okay, and they form a straight line, then they are supplementary. That's why we can say these things are supplementary. It's the linear pair postulate. So that's option A for me. As you're checking yours against mine, I'm not sure how I set this question up. These might, my option A is linear pair postulate. Your linear pair postulate might actually be option B, C, or D. Okay, these might move around for each person, so just pay attention to that. Now measure of angle ADF plus the measure of angle FDB equals 180. Okay, well we knew they were supplementary up here in F1, so now if they are supplementary, we can actually rewrite that and say that this is the information, this is the equation we get from that vocabulary word, and that's the definition of supplementary angles. If angle 4 is complementary to angle 5 and angle 6 is complementary to angle 5, then angle 4 is congruent to angle 6. That is the idea that if two angles are complementary to the same angle, then they're congruent to one another. That's the congruent complements theorem, which is option B here. 28. Okay, I'm just trying to get you to write your properties here, recognize your properties. This one here is the reflexive. Okay, when something is congruent or equal to itself. This one here is just all we've done was we flipped the sides of the equation. If I draw that vertical line down the word then and fold on it, I will get TW to fall on TW and RS to fall on RS, so that's the symmetric property of equality. 5y equals negative 20, then y equals negative 4. That's division. Okay, divided both sides by 5. Here, 2 times quantity a plus b gives you 2a plus 2b. That's distributive. If 2x plus y equals 70 and y equals 3x, then I can take 2x plus 3x equals 70. So all we did is here, we took this first equation, and where I saw a y, I replaced it with this 3x. So replacing with something's equal is substitution. Here it says if AB equals CD, CD equals EF, and EF equals 23, then AB equals 23. That is the transitive property. There's a linking from AB all the way to 23. If x plus 5 equals 16, then x equals 11. That is subtraction. If z over 5 equals 10, then z equals 50. We're going to use multiplication there. Okay, remember I said if you have a fractional coefficient for your variable, you want to multiply to both sides. If a equals b, then a plus 5 equals b plus 5. All I've done, I started with an equal statement, and I added the same thing to both sides, so that's the addition property of equality. If angle 1 and angle 2 are supplementary, then measure angle 1 plus measure angle 2 equals 180. That's the definition of supplementary angles. If angle 1 and angle 2 are a linear pair, then angle 1 and angle 2 are supplementary. That's the linear pair postulate. If measure angle 1 plus measure angle 2 equals 90, then angle 1 and angle 2 are complementary. That's the definition of complementary angles. If measure angle R equals 90, then angle R is a right angle. That's the definition of right angles. If AB is congruent to WZ, then AB equals WZ. That is the definition of congruence. I write the two statements from the biconditional. You live in Washington, D.C. if and only if you live in the capital of the United States. So we read it as if you live in Washington, D.C., then you live in the capital of the United States. If you live in Washington, D.C., then you live in the capital of the United States. So option A. And then we read it backwards. If you live in the capital of the United States, then you live in Washington, D.C. If you live in the capital of the United States, then you live in Washington, D.C. That's your two statements, your two conditionals that you can get from that biconditional. If possible, use the law of detachment to make a conclusion. Remember, the law of detachment is going to say a particular if-then statement and then give you an additional statement, and you got to see if this matches up, this additional statement matches up to the hypothesis. So if a doctor suspects their patient has a broken arm or broken bone, then they should get an x-ray. This doctor should not take an x-ray. So what we're doing is we're asking, does this phrase here match up with the if part here? Okay, and for mine, they don't match up. So there's no conclusion. Okay, so we got to find out here. It is not possible to make a conclusion using the law of detachment because the second statement does not match the hypothesis of the given statement. So option B there. Okay, let's see if I can get a different one here. Okay, this is really the same question, but they give me a different second statement here. The second statement says that the doctor suspects Lily has a broken arm. Well, that statement there does match up with this statement here. We got a broken bone. Yes, they match up. So from the law of detachment, it tells me I should then do that for this scenario. Okay, so the conclusion is the doctor should take an x-ray. Option D there. Okay, so you got to match up the law of detachment, match up that second statement with the hypothesis, and if they're a good match, then the conclusion of your if-then statement should be applied to your second statement. Okay, this is the law of syllogism. Law of syllogism is saying that we're going to match up a hypothesis with a conclusion Okay, and if those match up, we can rewrite a third conditional statement. So kind of walk through. So if mom finds out, then I'll get a spanking. If I get a spanking, then I will cry. We notice that that conclusion matches that hypothesis. So what we can do when they do match like that is we can write that phrase then as our new if-then statement. So if mom finds out, then I will cry. Option A should be my answer there. Okay, let's see if we can get a different one here. See if, okay, if Roger gets a new computer, then he will give me his old one. If Roger gives me his old computer, then I will have two computers. Well, he'll give me his old one. Roger gives me his old one. Okay, those match up. So if Roger gets a new computer, then I will have two computers. That phrase right there is perfectly fine to make. Okay, here it says, if we cooperate, then we'll get the job done faster. If we get the job done faster, then we can go, I guess this is the same idea. Since that one matches that one, that conclusion matches that hypothesis, and then I can say, if we cooperate, then we will go to a movie. Alright, so working through this proof, if they say they're supplementary here, and in the next line they actually write down for our particular problem that two angles add up to 180, that's going to be the definition of supplementary angles. Okay. Then we look over here and see what we're doing. Okay, they take CDE, which now they call it X. If I look at CDE in my picture, it's that angle there, they also call it X. So replace that with that. Then EDF is 3x plus 20 in my picture, so they take EDF and replace it with 3x plus 20. Well, replacing things with their equals is called substitution. They then add the x and the 3x. So we got to look here and see what our options are. That's going to be the distributive property for us. Subtract 20 from both sides, so subtraction property. And then we're going to divide by 4, so that's the division property. Here we want to identify what is going on, what's the property. If n is congruent to z, then z is congruent to n. All right, that's just flipping things. That's the symmetric property of congruence, because it's a congruency symbol. So symmetric property of congruence right there. 34 is another proof. Okay, C is the midpoint of AD. We look at that. That's given. Okay. Now AC is congruent to CD. Because of that vocabulary word midpoint, we're able to reach this argument here that AC is the same thing as CD. So that's the definition of a midpoint. Now all we do is we go from congruency to equality. Congruency to equality, that's congruent segments have equal lengths, or we've seen it as written as the definition of congruency in class. Now how do they go from AC equals CD to 2x equals negative 2x plus 12? If I look at my picture, AC's distance is also called 2x. CD's distance is also called negative 2x plus 12. So all they would do is replace AC with 2x and CD with negative 2x plus 12. So that replacement is called substitution. Okay. Now they're going to do the addition property of equality. So I'm going to add 2x to both sides. So that's going to give me 4x equals 12. And now they're going to get 4x equals 12 goes to x equals 3. That's got to be division. Here they want to use the reflexive property, so this is going to say angle JXR. Okay, so reflexive says that something is equal to itself, or congruent in this case. Here they want the symmetric property, so they say YXP is congruent to angle KUW, so then we got to say angle KUW is congruent to angle YXP. .37 here. Okay, we did this proof in class. Okay, angle 1 and angle 2, angle 1 and angle 3 are vertical angles. Angle 1 and angle 2 are supplementary angles that formally a pair supplementary. So then angle 2 and angle 3, if we look at those two angles also form a linear pair. So that is going to be number 2 here. Angle 2 and angle 3 are supplementary, okay, because of the fact that they're a linear pair. Okay. Now, number 3 here, we got to fill in the number that goes here, 2 and 3. Well, they were supplementary. That's what we came up with up here. So they must also be 180. So 3, I got to click on the 180 here. And that reason is going to be, why do I know 1 plus 2 is 180 and why 2 plus 3 equals 180? It's because I knew up here that they were supplementary, and that's the definition of supplementary angles. Now, step 4, okay, all they do is they take, since these two things were equal to 180, okay, so we had 180 both in these spots, so then these two sums should be equal to one another as well. Okay, so that's what we say in step 4, and the reason for that is either substitution, or because substitution is not an option here, it's the transit property. Then we recognize that angle 2 is on both sides, so let's just get rid of that, and that's how you're going to use subtraction. Okay, so if I get rid of 2 from both sides, I'll have 1 congruent, or 1 equal to 3. Measure angle 1 equals measure angle 3. And then we go from angle 1 to, or measure angle 1 equal to measure angle 3 in step 5 to angle 1 congruent to angle 3 in step 6. And the only thing that changes is the congruency symbol, so our reason there is definition of congruence. If angle 1 and angle 2 are both supplements to angle 3, then angle 1 and angle 2 are congruent. That's the that's the congruent supplements theorem. Angle 1 and angle 2 are both supplements to angle 3, then angle 1 and angle 2 are congruent again. So that's the same question. Okay, here we wanted to set up a system of equations. If we look at this, we look at those two angles there, they form a linear pair. So I'm going to say x plus 2y plus x minus 2y equals 180. And then if I look at those two, they form a linear pair. So I'm going to go x minus 2y plus 50 equals 180. Now, if this was the first equation I came up with, there's two variables, that would have been an issue. But if I look here, I still have two variables, but that 2y and that negative 2y cancel each other out. I get 2x is equal to 180. X then ends up being 90. Now, if x is 90, I should be able to come over here and plug in 90 minus 2y plus 50 equals 180, and now I can solve for y. 90 plus 50 is 140, so I get negative 2y is equal to 40 when I move those over. So those come over here, give me the 40. I will then divide by negative 2, and y ends up giving me negative 20. Now all I have to do down here is to find this red angle. Well, that red angle is vertical to that angle. So if x was 90, okay, minus 2y, okay, so 90 minus a negative 40, because 2y would be negative 40. Okay, so I'm going to get 90 plus 40, which is 130. So that angle right here is 130. So this one has to be 130 as well. I guess that the red one, there we go. That has to be 130 as well. So the red angle is what we're looking for. Here they want, again, we're going to have to use vertical angles. They want x and y. Okay, so I look at that angle there and that angle there. They are vertical. So I'll say 2x plus 4 is equal to 40. Remember, vertical angles are congruent. Okay, so that's going to help me find x. 2x is equal to, I'll subtract 4 from both sides, you get 36. So x has got to be 18. Okay, I got to find y as well, and those two angles there are vertical. So I'll set x is equal to y minus 2x. Okay, well, if I start simplifying this, I can go, so I know x to be 18, so I go 18 is equal to y minus 2 times 18. So 18 is equal to y minus 36. Add 36 to both sides. I'll get y is equal to, 54? Y is 54. 42, same type of question here. Still dealing with vertical angle. Should be a little bit easier, I think, than the last two. They say angle 1 is 2x. They tell me angle 2 is y, and then angle 3 is 70. So I want to find these angle measurements. So I want to set 2x equals to 70. There's a relation because they're vertical, so they're equal. So x ends up being 35. Okay. Now these two angles have to be a linear pair. If one of them is 70, the other one has to be 110. So y has to be 110. Vertical angles again. So I'm going to go 5x equals 84 minus x. Add x to both sides, you get 6x equals 84. 6 goes into 8 one time. It would leave me at 2 there. 6 goes into 24 4 times, so x ends up being 14. Now they want to know what is that angle there. Well, if x is 14, 5 times 14 is going to be 70. So that's 70 degrees. If these are vertical, that also has to be 70 degrees. And if I think about 84 minus 14, does give me 70. Complete the following theorem. Says if two angles are congruent and form a linear pair, then each angle is a right angle. Okay. If you have any questions about this test that I didn't cover in the review, please feel free to stop in and see me, and I can help you with those questions.